Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management.
I'm Darryl Taft. I'm the news editor for the New Stack. I'm joined today to talk about the future of TypeScript with Luke Hoban, who is the CTO of Pulumi and also one of the co-creators of TypeScript. Along with him, we have Daniel Rosenwasser, who is Senior Program Manager at Microsoft on the TypeScript team, and Ryan Cavanaugh, who is a Principal Software Engineering Manager at Microsoft, who's also part of the TypeScript team. And my colleague, Joab Jackson, who is our editor-in-chief, will be joining me. Because we have Luke here, I'd like to start off by asking, tell us, how this thing all started and what was the impetus behind TypeScript?
Sure. I can give my version of the history, and then, maybe some of the other folks here who are still working on the project today can kind of talk about how that's changed over time as the project's continued to grow. From my perspective, I had worked in the developer tools group in Microsoft for many years. We were working on things for C#, and I think other folks, Ryan was working on VB and other parts of .NET platform. And I think we saw it within Microsoft back at that period of time, there was this huge rise of kind of a need, teams within the company, to move a lot of developers from developing, sort of C++ applications like for Word and for Office and for Windows and things like that. They were moving a lot of developers over to build web-based applications as they were moving to, move Office onto the web, more and more complex sort of software and applications into web-based platforms. And one of the things that those teams were coming to the developer tools group at Microsoft asking about was, when we move these developers over to JavaScript, we're losing a lot of the tools, a lot of the capacity to refactor at scale, to build large software that our teams were used to. And so we're having to invent a whole lot of new solutions to these problems. And there were a lot of various sort of solutions that were being built sort of independently by different groups, both inside Microsoft and in the broader ecosystem at Google and other companies that were also doing this at the time, and in other parts of the community. And none of those solutions quite got the experience to where folks wanted. They solved for specific things, like we had solutions that let folks bring, Script Sharp was a solution that let folks use C# to compile into JavaScript, but it kind of kept you at arm's length from the platform. There were other solutions that took other approaches. With TypeScript, we sort of set out to see if we could really solve that. How do we make it possible to build, I think at the time we called it application scale, but it was really just sort of larger applications that folks were trying to build. How do we give folks the tools to do that when they're targeting the web platform? And by the web platform, that meant really JavaScript in the browser and all of the richness that was supporting. And that platform was growing incredibly quickly, right? The HTML standard was moving fast at that period of time. ECMAScript, JavaScript standard was moving fast at that time. So this platform was getting very rich. A lot of really rich applications were being built on the V8 engine and the Chakra engine were bringing performance to that platform. And so this tooling piece was sort of one big missing part of that. And I think the project really started with Steve Luco, who was one of the kind of architects who had worked on the Chakra engine at Microsoft. And I started talking about this opportunity, started doing some sketches of what this might look like, started reviewing that with a few folks within the organization, including Anders Helsberg, who obviously has now been one of the leads for the project over the whole span of it, and continued to kind of grow the project. And about a year and a half later, ultimately shipped kind of the first version of it to the community.
Was security an issue that you guys considered?
I can give a first answer to that from the historical perspective, and then I'll let others kind of answer maybe from the current perspective. For security, it's interesting. JavaScript fundamentally has some good security properties, and that's one of the reasons why it's a good fit for kind of being the language and the runtime environment within the web browser, which it has to be a very sort of untrusted environment in a sense. And, it has memory safety. It has a very rich kind of runtime environment that is very sort of protected and sandboxed. So JavaScript fundamentally has some good sort of security properties. I think the thing that TypeScript brings, from my perspective, on top of that is, a number of the sort of security issues you end up having when you get past buffer overruns and that sort of thing, which isn't really fundamentally kind of a problem in JavaScript. You then get to more sort of like logic errors that developers may make where they're not correctly handling input data in a way which they need to have the right behavior for their components. And TypeScript, I think, fundamentally helps by bringing types, bringing static type checking. These are tools that fundamentally help developers to sort of create more correct code by default. And so I think TypeScript has an important role to play in enabling developers to create more correct, kind of applications. But I think the combination of TypeScript and JavaScript and the battle hardening of the JavaScript engines and the browsers is great from a security perspective. It's one of the reasons why JavaScript shows up as a sort of sandboxing environment in a lot of different contexts. But curious what Ryan and Daniel have
I think there are a lot of places where the JavaScript built-in API or functionality provided by other libraries, without types, you can sometimes get yourself into trouble if you're not sure what the correct and incorrect ways to call something are. Because, for an example, like you can call parse int and give it a number, and that number will be converted to a string and then back into a number. And you might think that that's a fine thing to do, but there are like hostile inputs that can show up here that will not round trip correctly. It's not as much of a security issue as, I guess, a data corruption, but data corruption can lead to a security problem. And making sure that you're always calling things the right way is just part of that. Security is about logic errors too, but it's also about just kind of data integrity and making sure the application is doing what you think it's doing at all times.
To add to that, when it comes to security, a big issue in the JavaScript world tends to be stuff like you incorrectly evaled something or you accidentally displayed some untrusted input onto the page, right? So there are some efforts independent of TypeScript. There's an effort called trusted types where basically your server says to the client, hey, I want you to actually validate that anytime that you're about to put something into a slot in HTML, like that needs to be a validated string in some capacity. TypeScript doesn't actually help in that capacity directly because that has to be runtime enforced. You need to basically make sure that you're not just arbitrarily putting a chunk of untrusted stuff onto the page. But TypeScript actually provides really solid tooling early if you're able to leverage that, right? So if you're able to say that in each of these places on the page, I need to take a trusted string instead of an actual string, well, TypeScript supplements the experience because the actual enforcement is in your browser, but you get a hint when you're editing in your IDE or editor or whatever with a little red squiggle saying, no, you're putting an arbitrary string here, but I need something that's actually validated before you do that. So security is not really like primary thing, but TypeScript does provide a better experience and, some guidelines to help guide you away from some of the pitfalls that you might encounter in JavaScript in that way.
So for the JavaScript developer, the only fundamental difference would be I just have to establish the data type for whatever variable I'm adding, I guess.
To some extent, but I think a big part of the early design, and still now, is you're trying to win people over from JavaScript to TypeScript, right? So there's type inference. So a lot of the time, you don't need to necessarily write out an explicit type of like what this thing is going to be, right? This is a sort of a shift that you've been seeing for years in most mainstream languages where you don't need to say the type. You don't have to say list equals new list, right? Like that's not a thing anymore nearly as much. So you say like var list or let list or something like that. For inputs, yeah, like sometimes you do need to write out a type. And so there needs to be some sort of signal of your intent to the compiler. But yeah, for the most part, there's sort of a good balance there. Maybe Luke can speak to some of the early thoughts in that design.
Yeah, it was interesting. We kind of mentioned things like Scriptsharp as one of the sort of predecessors to some of the line of thinking here. I think one of the others was there was this class of tools back at that time, like a Closure compiler that was out of Google that was being used heavily inside Google at the time. They let you put comments on a lot of the things in your code that sort of annotated, provided additional information for tools, or actually for the original purposes, it was for minification. It was just to make the bundles of JavaScript smaller when they delivered them and to have some additional information to sort of influence those. But they eventually grew into more annotations to say, here's the type of this thing, or here's how this thing is used. And then those could be used for additional tooling, for static checking, for IDE tooling, that sort of thing. We saw those tools were actually very effective, but it was very cumbersome to kind of go put all these types in comments. It was very awkward. It was this whole nother thing you had to go kind of learn. The type system wasn't very expressive in a whole bunch of dimensions. And so one of the thoughts, the motivations was kind of the point Daniel made was, hey, the combination of can we bring that ability to express types into the syntax as a lightweight extension to JavaScript? But then can we still offer as much sort of inference as possible so that you need to use those annotations sort of as infrequently as possible so that the burden of this is low and feels pleasant to developers and the cost benefit of doing this is positive?
The thing I also think about is that the types are always there, whether you're writing TypeScript or not. If you write a function in JavaScript, you have to think about what kind of inputs you're going to be given. And TypeScript is really just a way to write down what you think those valid inputs are. Because if you expect a string and someone gives you a number, like something weird is going to happen. The types were there. We've just given you a way to write them down and validate them.
In the early days, I'd say what Ryan said is true. My perception of TypeScript today, now not working on it, but actually being more of a user of it and kind of building solutions around it, is that now TypeScript is quite a bit rich. I mean, the amount of help that TypeScript is providing, not even just strictly for types, but escape analysis, like so many different things that TypeScript is helping with to sort of identify correctness and other issues in your code. TypeScript is this really invaluable tool, I think, for a lot of developers where they have to put in reasonably little extra effort beyond their JavaScript, but they get back a ton of additional value, both in terms of that static checking and validation they get, but also sort of the IDE tooling and all the things downstream from that. I think that's the work, obviously, that other folks here have been doing over the last 8-9 years, I guess it is.
I want to add one more point to that. I mentioned type inference a little bit ago, right? This idea that you didn't have to actually write the type out every single time if you could help it. There's sort of another axis to that, which is how often do you have to convince the type system of a more specific type, something that I know better than the type system. That's a big pain point across any type language, because you have to make some concession at some point. You have to actually say, like, I know a little bit more, trust me on this one. And in some languages, it's, runtime enforced, and TypeScript, it's sort of just like a trust thing. But one of the things that we did years ago, starting really in the 2.0-ish timeframe, was we started really doing control flow analysis to try to understand how the types flow throughout your program. And the thing about that is, the sort of guiding principle there is the less you have to kind of think that you're in TypeScript, the better that experience is, right? So basically, what we do is we look at existing JavaScript patterns and we say, like, how do we encode that in a way where we just kind of automatically pick that up and pick up how the types are flowing through your program. So you're just really writing JavaScript at the end of the day. You're not really thinking, I need to do this because TypeScript is happy. I need to do this because this is like the way I was going to code anyway, right? So we try to look for those sorts of patterns.
Are there classes of programs or applications that are better suited for TypeScript over JavaScript? JavaScript being, of course, fundamentally a language for web applications, but does using TypeScript bring you to a plateau where you can do more serious types of computation, I guess, rather than front page rendering?
I don't think so necessarily. I think it's sort of what Luke had said initially about scale and really complexity, right? As soon as you're trying to figure out like the flow of data in your program, this thing starts in your mind and it ends up in like the ether, right? Like, where did that design go? Who knows, right? Whereas types sort of give you a guiding map of like, okay, here's what I originally thought out. Does that still make sense? Can I come back to that? Can I get an overview of that? Can someone new to the team come along and onboard without me having to like take an hour at, a whiteboard and trying to understand that and rebuild the whole context from like when I first built it or something like that. So you're starting to see much richer and more complex applications at like this sort of scale, which would not have been possible otherwise, right? So like very early when I joined the TypeScript team, you were hearing testimonials from what was the precursor to the VS Code team called Monaco. Even today, they'll say like, this project would not have been possible without TypeScript, right? You see very large applications being written with TypeScript today where like it's possible, just way harder and not practical for most people.
I think it's funny too, because we talk about kind of large scale application development, but what I find even in my day-to-day life is like last week I was writing a script, just like a one-off script. I literally only needed to run it once ever. And I was like, well, I'm just going to write this in JavaScript just to skip the transpile step today. I'll try out JavaScript. I still love JavaScript, right? And I had a bug in the program, it didn't work. And I just was staring at the screen. I'm like, oh, what's going on here? I'm like, you know what I'm going to do? I'm going to turn on TS check, which kind of enables the TypeScript errors, your JavaScript files. And immediately TypeScript told me what the problem was. And I was just like, oh, here's your bug. And I fixed it. And I got back to doing real work again. And it was like, yeah, this is just great everywhere, even on the smallest script.
Two kind of additional pieces on that. One, like what I'm working on today, at Pulumi, we kind of build the ability for folks to sort of take, existing programming languages, including TypeScript, and sort of use them to describe cloud infrastructure. And one of the things that I find, from a TypeScript perspective is like, we let folks use both JavaScript and TypeScript and Python and a bunch of other languages. But when it's in TypeScript, it's sort of this magical experience because you get all this feedback as you're writing. And even if you're writing a very small thing, if you're just deploying, an S3 bucket or something, some very simple thing, you go in the IDE, hit open curly brace on your parameter list, and it tells you here's all the properties. You forget to provide one of the required properties that you need. It's giving you a red squiggle saying you didn't provide this required property. You hit control space, you get all the help text that describes how that property of S3 works, right? And sort of everything about the cloud platform. And so developers using that platform, even if they're not really thinking about it as TypeScript versus JavaScript or whatever, just the productivity experience that they get. And that's not specific even to what we do at Pulumi. That's true for kind of any application of this kind of tool chain. But it just provides this really rich, productive experience on top of this platform. That doesn't change what you can technically do. But to Daniel's point, it just changes the practical nature of how quickly you can sort of achieve that, even for small things.
What are some of the things that Microsoft's doing with TypeScript?
I don't want to say every because I don't know what's going on across the entire company, but I think all JavaScript development at Microsoft is effectively happening in TypeScript now. So we hear a lot of internal feedback from people within the company using TypeScript to develop their applications, which is a really great source of feedback because we can talk to people, dig into their big code bases and understand how to help them out. Yeah, I know we've got some stuff going on Azure where we're making it easier to do TypeScript development in Azure. Daniel, you probably know what else is going on.
Literally every Office property, for example, now uses like TypeScript in some capacity if it has a web presence, right? Same with practically everything on Azure, Xbox, many different things. And of course, like, if you've been coding in Visual Studio Code, even parts of Visual Studio now are written in TypeScript. I believe there's certain parts that use a little bit of TypeScript in there as well, right? So it's found its way in every little place because JavaScript has a lot of convenience, or it's like the best way to target every platform. And TypeScript enables you to actually build the app using that platform. It's hard because there's just often so many that you're like, oh yeah, them too, right?
Like Teams as well, yeah.
I mean, the amazing thing from my perspective, not obviously being at Microsoft, is not just, hey, just about everyone at Microsoft's using this. It's really just about everyone in most large companies tackling big problems where they're touching the web in a meaningful way. For any serious large-scale endeavor, there's a very, very high chance today that that's being done with TypeScript, or the team is looking at how to get to TypeScript in some incremental way. And I see that across big companies in the industry. I was working at Amazon for a little while, saw a lot of TypeScript at Amazon and AWS. Obviously, we now see it from the customers we work with across all kinds of different industries, and totally different space where it's the cloud, not even kind of the browser. The breadth of adoption is really quite striking to me. I think TypeScript is sort of now like the number 8 most used programming language, according to some of these things. And I think it's been the fastest language to enter the top 10, basically, since we've been reporting on this stuff. And I think that's largely because of the growth of JavaScript. TypeScript's come along, but TypeScript just provides some really great value for cost on top of that. I've seen an amazing uptake thanks to the great work of the team.
What are some of the standout projects that are done in TypeScript outside Microsoft?
I'll give 2 examples. One that was in Microsoft that Daniel talked about, but I think is actually really important. It was sort of a big part of my engagement with TypeScript early on. When we started the TypeScript project, actually, I think within about 2 months of starting the project was when the sort of predecessor of the VS Code team also was getting started at Microsoft. Eric Gamma had joined the company right around the same time and was starting to think about building a web-based IDE experience, and kind of fundamentally knew that was going to be a complex JavaScript application. And those 2 projects sort of were being developed basically together. He was the first customer of TypeScript, and his team were the first customer of TypeScript by a long shot. They were using it when it barely even worked at all. And the first thing that they built was IDE tooling for TypeScript because they wanted to be able to self-host and use their IDE for themselves on their development. And so I think those 2 projects played hand in hand, and obviously both have sort of now independently had a pretty enormous success. And so that's been really great to see. One other project kind of in the relatively early days I think was important was when Angular actually took the decision to kind of really lean on TypeScript as the default kind of authoring model. That was one of the first really big outside of Microsoft framework level adoptions of TypeScript, where it wasn't just one engineering team adopting it. It was kind of a whole platform, a whole framework. And I think that was a big inflection point in my mind for kind of TypeScript's overall sort of momentum in the industry, was Google and the Angular framework deciding to kind of use that as the foundation for that framework. And I think we've now seen that same thing happen with other frameworks.
I would say almost every major front-end framework these days, library or framework or whatever, is actually written in TypeScript. It's pretty hard to come by one that isn't. And it's because of a lot of those benefits that Luke kind of pointed out of like, hey, our users get this amazing editor experience when we write in TypeScript, right? That was a really big milestone. Like, we were starting to see, oh, well, Vue 3 is also written in TypeScript. Oh, this framework is also written in TypeScript. That was very rewarding for us. We really wanted to reach out beyond Microsoft, right? Like, this is something that was mentioned. We didn't want to have this weird thing where it's like, oh, well, if you join Microsoft, you have to use this language called TypeScript. It's like, that's not what we wanted to get to. We wanted to make something that would kind of grow beyond that. And so, you see really great things like from Pulumi, they really do think about, for example, hey, how does this work with TypeScript? You get a good experience when you use this. Then there's a lot of products, really cool things. Slack Desktop, for example, uses TypeScript. Some really cool things like Figma use TypeScript. There's also this effort within Microsoft called Fluid Framework of trying to make it so that you can get something like Figma or like the collaborative editing in like Docs or Word or whatever that you can use, and that's written in TypeScript. That's a pretty cool use to see like a lot of these newer ideas of opening up new paradigms for people and kind of lowering the barrier to entry is going to have TypeScript as a first-class citizen, and also those stacks will probably be written in TypeScript too, right? Just because of the complexity it requires in some cases. And then you see, like Luke said, Google's got TypeScript as a first-class citizen now. I think most, if not all, new projects at Google are using TypeScript, Dropbox. It's really hard because whenever I think about this list in my head, I'm like, who am I forgetting? There's someone I'm forgetting. There's too many people, because it's like, who is not using the language at this point?
When I first reported on TypeScript, the thing was that Microsoft invented it because there was issue with building large-scale apps with JavaScript. So how big of an app can you build with this? Can you name any big apps that have been developed with TypeScript?
Some of the things that Daniel talked about, before, like Azure. You think about how much front end code there is across all the Azure portals, all the different user experiences. You think about the Office web applications; these are enormous things. You think about some of the Google front end properties. These are enormous things. Just Figma, that's an amazing, incredibly complex. All of these are, I don't know the number of lines of code, but they're incredibly complex, large-scale applications. And really, there's no clear indication there's sort of an upper bound, I'd say. Like, this has been used for the biggest things that have been built into the web platform. And today, I'd say most users don't really think about the richness and capabilities of web-based applications any differently than they do native applications for mobile or desktop. Users are accustomed to now having as rich of experiences inside the browser as they do elsewhere. And I think some of the richest of those tend to be built with TypeScript.
I think that's accurate. We've definitely seen millions of lines of code within the company. And then at some point, someone posted an issue on our issue tracker that was like, just curious, what's the biggest code base that you've seen in TypeScript? And they were like, not to brag, but we've got like 20 million or something like that. And we were kind of shocked. Simultaneously shocked and not shocked, because it's a lot of code, but at the same time, like, it's not implausible, right?
Last week, we ran a story about AssemblyScript. I guess you would call it a variant of TypeScript that allows you to write WebAssembly modules. Is there a possibility of TypeScript moving beyond browser apps and maybe having it compile to other platforms as well?
I think JavaScript is kind of the future of almost everything at this point. I think AssemblyScript is really cool, but it's a really interesting variant for someone else to take on. We're really committed to this idea that you take JavaScript and you paste it into a TypeScript file, and it still runs the way that you wrote it, which is like an invariant that AssemblyScript doesn't have, which it absolutely has to, and it makes a lot of sense for them. We're still focused on JavaScript as the ultimate backend. I think you'll see JavaScript just running in more and more places faster and faster, and there's going to be more innovation going forward in the runtime space. That gap is going to be closing the longer that people keep working on JavaScript engines. So we still believe in JavaScript as like kind of our compilation target. If other people want to do cool stuff like AssemblyScript, like, that's really cool too. I'm excited to see what they do there.
In Pulumi's case, the company actually allows you to write TypeScript in order to control your infrastructure, being one of a number of languages that you can do to use that rather than use Chef or some other language that you have to learn. I mean, am I getting that correctly? Is that basically what Pulumi is offering?
Yeah, instead of being in the sort of the front end development space or in the sort of server side, kind of back end Node.js developer space where TypeScript has already had, a lot of success kind of in both of those. I'd say Pulumi is sort of in what's talked about as the infrastructure as code space, which is where we take the cloud infrastructure we're managing and we write that down as code, and we use the fact that it's code. A lot of the same reasons why TypeScript is beneficial, for web development, where it helps you to scale up the complexity of what you're building. Languages, and in particular TypeScript, are really valuable for cloud infrastructure, where folks maybe used to be managing a handful of things, just like they used to be managing small scripts in the web browser. Now they're managing tens of thousands of resources. Those things are changing quickly. They've got real software complexity they've got to manage. And so bringing those languages into the infrastructure and cloud management space is increasingly important for organizations that want to sort of get the most value out of the cloud platform. And so it's a lot of the same motivations as what motivated us to kind of do TypeScript in the first place. And I think we're now, kind of working on bringing that. We're not the only ones. There's other folks. Amazon has the CDK project, which is also kind of started with TypeScript and has expanded out into some other languages for kind of tackling some of these same things from an Amazon cloud perspective. We're doing that in a multi-cloud perspective, working with a lot of different cloud platforms. But we're seeing that these same paths of this kind of tooling approach, the ability to control and manage complexity at scale in the cloud, is sort of one of these new frontiers that's sort of opening up. And we see an enormous opportunity to help server organizations get value out of their cloud, just like we're helping them get more value out of the browser as a target or the server side with Node.js. So I think there's innovation across these things, and we're playing one part of that right now.
Can you talk about some of the features that developers have been asking for? What's been added to the language, and what are some of the things that people are looking for to be added in the future?
One thing that we recently added, it kind of ties into, how much power are we giving users within the type system, right? So with type, you're often trying to relate to the compiler, the type checker, what is the behavior of this function? Like, what is it going to return? And a function can literally do anything that it wants with whatever values you plug through it. So sometimes you want to communicate, it's going to take an object and it's going to create an identical object with all the property names lowercase or something like that, right? And so we have a lot of expressivity in our type system, and we built up many constructs over time in the type system to the point where when you create a type, you're actually kind of running it through a mini programming language within our type system, right? So people have kind of proven that TypeScript types are Turing complete, right? Like you can run a small program and then you can do addition and do logic and write a mini interpreter. In practice, you can't get that far with it, but you can go pretty far. One thing that we've recently done is we've enabled people to write recursive types in a way that is optimized and allows you to go a little bit farther there, right? So you can actually do this thing where like you do go through all the letters of a string and parse it out in some cases. We're not trying to go crazy with it. We're just trying to enable the right patterns where you're actually able to express what your JavaScript is doing at runtime. We don't want people to go overboard, but we're trying not to like get them stuck in some cases. There's this pretty cool feature of like tail call optimization that kind of landed in TypeScript, which is sort of like a braggy feature. It's a thing where like library authors can use it and then everybody else sort of benefits from that. Then another 4 or 5 feature that recently went out is just like, not everything is like going to be perfect 100% of the time. We've been working on ways just to make sure that when people use promises, it just sort of works, right? And we've built in some new construct into the language, try to make sure that when you await something, you get something that's consistent with when you use a promise and all this other stuff. And so that sounds maybe a little bit less intense, but it's sort of the same playing field of like empowering library authors to write the right code so that every user benefits. So that was like a longstanding pain point that we were trying to work on, but it all ties back to really beefing up the type system and sort of the base primitives that are built into TypeScript too.
Kind of curious, this is not really your domain, I guess, but has there been any talk in the ECMAScript community about adding types into JavaScript itself?
I think that has come up. It's something where it would take a lot of work. It certainly is not out of the question, and it would bring a lot of really interesting benefits, right? You would not need to have a compile step, right? Being able to like take your code and just hit F5 refresh and not have to worry about, do I have a bundler and a compiler and all that stuff set up? In the browser world, people have a tolerance to this because you've had to have a tolerance to this because if you're going to do any sort of browser-based big application, for all intents and purposes, you need a bundler, right? Before it was also a compiler to downlevel your syntax because you were trying to target every browser out there. And that's becoming maybe less the case for some people, but a bundler helps there. But like in the server-side system, it's a little bit tougher. People are not used to compiles or whatever in Node nearly as much. So it would be exciting, but it's something that would take a lot of work. And a lot of people need to come to a shared understanding of what that's going to be, right?
There are varying levels of what people mean when they say types in the browser too, which is, I think, if maybe 3 or 4 levels, we'll see how many come out of my mouth. But at the highest level, you would have static verification, where like before the program runs in the browser, the types would be verified the same way that they are like when you run the TypeScript checker. Maybe a level below that would be runtime checking, where you annotate some function as taking a string. If you pass it a number, you get an exception instead of just like data corruption. And then below that, the types are sort of just comments that you can read in your source code but don't have any effect on the runtime. And we've talked with the committee about different ways that we can think about this, and there have been various proposals. And I think the sort of annotations only model is the one that looks most likely to be successful, just because otherwise it's easy to reason about like, is a string or number, but when you get into like much more complex types that TypeScript lets you write, having the runtime evaluate those questions in a consistent manner is a lot more difficult. It's not something that there's a lot of appetite for figuring out.
I'd like to thank the TypeScript team at Microsoft, Luke Hoban from Pulumi, and also thank all the viewers. Keep in touch and watch out for our New Stack Makers podcast.
Thanks for having us.
Yeah, it's been amazing to see, the growth. It's been amazing to see what the team has been continuing to do in the broader community. It's exciting, and I think it's great to kind of capture the state of where this is. So thanks for having me.
Thanks for listening. Subscribe on Simplecast to listen to more episodes of the New Stack Makers. Then create and share your favorite audiogram using our Simplecast player. For more great stories, go to thenewstack.com.